Science really isn't as complicated as you and many of my former colleagues think it is. It can't be, if I was able to do it. Check out, for example, a piece called Science Angst, if you don't believe me. Hi, my name's Alex. I've argued enough for a lifetime. In this series of videos, I zoom in on the perspective science can give you. Find the playlist at the end of this one. 'Cause nature's complex, science isn't. On to the ultimate beginner's guide to science. I remember him smiling. He did so more often than I realized at the time. He was my supervisor, Professor Havnes of the then University of Tromsø in the north of Norway. "You can't take that term away," I told him in one instance. "Why not?" he asked, and entered into one of these marvelous little lectures on how to weigh that term over this term, based on the situation the equation was supposed to be used in. I'm smiling too, thinking back to these conversations. I always ended up in a better mood for having had them. He never knew it, but he taught me more or less everything I know about leadership. Not physics. I know next to nothing about physics anymore. Leadership. He would say, "See, the particle density is this and this at the bottom of the mesopause, so that means that this term becomes that order of magnitude, I think, when we launch our rocket up into it, and that means it's 2 orders of magnitude smaller than this term, at least, and you don't need to think of it for as long as you restrict your model to the largest particles in the Noctilucent clouds. I don't know." I learned that he was right when he ended his thoughts with, "I don't know." He was wrong too, sometimes. Often enough actually, but big time once, because he didn't even consider that his experiment may have not gone as well as it should have been. In 1996, he and his team had launched a rocket up into the mesosphere and into technically into a layer of dust which produced polar mesosphere summer echoes. Those have to do with radars and stuff, but let's say into Noctilucent clouds. That's close enough for us. And the results surprised everybody, not just him. There were measurements of positively charged particles, ions of some sort or other. Now, that doesn't sound dramatic, but to him and his colleagues it was a point of contention. And contend they did. Oh, how they contended. They argued and yelled at each other, basically. Then, 21 years later, when I was his student, he told me, "Oh, by the way, about," and I quote, "a model that needed redoing, because in some other experiment they had seen Noctilucent cloud particles hitting the wall of some bucket on top of a rocket and fragmenting." Don't worry about the details, but he found that those positively charged particles may have just been a consequence of the experiment design, not something which actually existed up there in the air. Thus, he and another student of his changed the model, the positively charged particles were no longer necessary to explain things, and they wrote a sort of mea culpa paper telling everybody else that he had been wrong. And that's almost true. The process of science doesn't work that way. They wrote the paper, of course. It was accepted, published, and led to new experiments of which I, amongst others, was allowed to partake. The mea culpa came at the end of the days during the summer's conferences, when everybody had had a beer. No worries and lots of stories of old fights. Good times, as literally as possible. Which brings me to the many conversations I've had with people whose background does not lie in science. All too many of those have no idea that we are people. If that sounds weird to you, then that's exactly what I mean. We are, and you kinda know we are. But for some reason, whenever a scientific word such as experiment or evidence enters the conversation, the blinders come up and we become laughable, funny cast members of a certain unmentioned sitcom who, interestingly, sit in plush and mighty ivory towers at the same time. In one of the other videos I talked about this in terms of being put into these ivory towers, such that laughing about us doesn't feel like bullying. Then of course, there's a reason why we are so easy to be put up there with the demigods. We do things differently, we think differently. Just take Professor Havnes. Would you have had the guts to admit that you've been wrong 21 years before? Just generally? To be honest, I'm not sure I would have had the guts. But let's reiterate that story. In 1996 he wrote a paper. The experiment may actually have been a year or two before that even. in which he told the established mesosphere science community that they were all wrong. I say established because he wasn't part of that community then. His field of study as an astrophysicist were the rings of Saturn. Yet he told people who, and let's not forget that, had devoted their professional lives to studying the mesosphere, that there were positively charged ions up there, in the Earth's middle atmosphere. See, they didn't think that was the case before that paper in 1996, and why should they? And why would they? There were no experiments that showed them, and the models didn't indicate that there should be. Well, Professor Havnes's answer was to tell them that they all should rework their models. They all do begrudgingly because, now there is an experiment showing those positively charged particles. And then, 21 years later no less, he came along again and admitted that he had been wrong. And they were wrong in adjusting their models in the particular ways they did because, hey, April Fools! Within the science community, stuff like this is okay, because knowledge advances during this process of making and admitting errors. The others did stuff wrong too. They all argued after their fashion, some more, some less emotional, but they all pushed knowledge about the mesosphere forward by making mistakes. By the way, the mesosphere is where meteorites become gas. It's also part of the tricky volume for astronaut re-entry, in case you wondered about who cared. How exactly did they advance knowledge then? By thinking and asking questions that have answers. What's the last question you, as in you listening right now, asked? In my case, I looked at my cat and asked myself, why did she climb behind the TV and uprooted, if you will, all the cables? I didn't know, I still don't know, and probably never will know. So that's not a good question. Why questions can be like that? They can be dangerous when asked about other people or oneself. Why did I just do that? When you can't answer that question, things become iffy and often a little depressive. What would a good question be then? Well, think about the cat. Does she climb behind the TV and destroy electronic infrastructure often? That's a yes or no question. It's better, but not good yet. It's like looking up and asking, can I see the sun? Yes. Good. End of conversation. How often does the cat climb behind the TV and fiddle with cables? That's even better because now we could, in principle, if we cared enough, that is, set up a camera and find out. It's like building that laser from the Windy Day story and asking, how often are there atmospheric pressure waves over northern Norway? We can find out, and that's fine, but it doesn't help quite yet. How often does the cat climb behind the TV to fuzz around, and are there any patterns as to when she does it? Time of day, mood, availability of toys, that sort of thing. The experiment is the same, but we could analyze the footage of the camera with a different focus. That's what my professor did when he found out that he was wrong. He hadn't even grasped the whole situation 21 years earlier and looked at the experiment anew with a different focus. So, how often does the cat climb behind the TV to fuzz around, and are there any patterns as to when she does it? That's a clunky question, and it took some time to get there too. I'm not surprised it puts people off to think like that. You can't live a normal life like that, and when we try it, we scientists, we do start looking like sitcom characters. So no, I'm not saying this is superior day-to-day thinking, it's science, and it's geared to find out about nature. You know, the same nature that has black holes in it and mobile phones. Have you ever stopped and wondered about them? If not, go check out Science, Smartphones and Nerds. The trivia in that piece is a little wonky at times, but the overarching idea holds for all that. These little pocket computers of ours are awesome in all senses of the word. Without science, we don't have them, period. Of course, I have taken it further than this in other videos and connected science to empathy and leadership too. Again, Professor Havnes, unbeknownst to him, I think, taught me all I know about these things. But that's kinda it, nothing else. What's complex really is only nature herself. Science is based on a way of thinking you simply have to get used to. What is a good question? How do you have to look at these data points? What am I missing here? Can you help me, my dear colleague? The rest is exactly as I've presumed you know it already. Ask a good question. Set up experiments and find the answer. fit this answer in with other such answers to form a complementary hypothesis, and test everything as a whole. Test again and again, agree with the vast majority of your colleagues, and let engineers loose on the collected knowledge. After a while, something awesome will happen. The engineers will build stuff with your knowledge, say touchscreens out of your quantum physics, and the whole thing will become part of everyday life. It will become, in a word, a theory. Yes, that is how we use that word. Well, most of us do at any rate. String theory isn't a theory at all, for example, but you know what I mean. Theories. That's stuff like gravitation and, yes, the ever-irritating a particular section of society, theory of natural selection, and the actual Big Bang Theory. So, no, you don't have to do science in daily life, but you should understand it to the point where you find the idea of posing theories on, say, the performance of a hockey referee just a tad weird. By the way, if the title to this piece made you expect a bullet point list or some such thing or a tutorial, go watch the channel trailer. I can't do tutorials which I'd be happy with. I don't know what you already know, you know. But I can tell you how I see it with the help of my anecdotes, and hopefully I've put some thoughts in your head. I want you to ponder it all a little. Were there times when you could have profited from asking yourself whether your question really had an answer? Comment down below and let me know.